Hello, my dear students. Welcome you all. Welcome to Unacademy. This is your BU37 egg. And so, as you have seen the beauty of Unacademy, the toppers in GATE 2024 from Unacademy students only. You can have a look at now. 7 AIR ranks from Unacademy students only. You can have a look at now. For electrical, CSIT, ECE, and CH. IN, PI, NM, all these different branches, the toppers from Unacademy only. Right. Now it's time for you can start your serious preparation with the Unacademy. इसीलिए हमने आपके लिए बढ़िया से बढ़िया ऑफर लेकर आया. Yes, that is for GATE 2025. That is only 6,999 only. And this is an amazing offer which is valid up to September 30th only. Now, the top-notch content is the most affordable price. That is 6,999 only. To enroll for it, you can use a code of BVRD and have a great learning experience from the top educators. And so, Unacademy is providing another great feature, that is GATE Assure. With this, the student who has taken the 12 months and above subscription, so get the GATE Assure. Means, so until you qualify in our GATE exam, so we are with you. Yes, until you qualify in GATE exam, we are with you. To enroll for it, you can use a code of BVRD. I am there for you to provide you all type of required guidance and to provide the best and best knowledge to you. चलिए हम शुरू करेगा. And here are new batches we are starting. You can have a look at now here this flat 50% of discount which is applicable up to September 30th only. Use a code of BVRD to avail these opportunities. And for GATE, so here 2025, that is 6,999 only. Now, you can see now we are starting new batches. Have a look at now here from 28th onwards we are starting a new batches. And here the list of books the iconic students fellows can able to get. And here the list of EC books the EC students can able to avail. Right. So let's continue our discussion. Last class, how many problems we have completed? So I think so here last class we completed up to 42 or 43. 43 we have finished. Right. Chalo, next problem. Take this problem. How many 3x8 line decoders with enable input are needed to construct 16x64 line decoders? Right. So the decoded number of decoders is calculation is similar to the DMUX calculations. We have 64 by 8. How much you tell me now? 8 now. Simply divide the outputs and that is 8 by 8. So which will come to be a 1. So totally how many we can say? 9. Totally how many gates required? You tell me now how many required? 9 decoders are required. Next one. The following circuit implements a 2-input AND gate using 2 cross 1 mux. This is one 2 cross 1 mux. This is another 2 cross 1 mux. Now they want to implement this expression for this. What will be the values of x and y they are asking? Right. So A and B. So if I call this output is y1, can you tell me the y1 output now here? That is x1 bar into A plus what, tell me now, x1 into B. Next. And what about this y2? You tell me now here. Yeah, this y1 is this input and this, sorry, हमने उल्टा लिखा ना. So this y1 they given here 0, here 1 given na. So that's why y1 is what, tell me now here, x1 bar into B plus what, tell me now, x1 into A. Now this y2 is what? Tell me. x3 bar into x2 plus x3 into y1. Now, so this y2 value, so you can see now here, हमको क्या चाहिए? x1, x2, x3 required. So now, so y1, so if we see carefully, y2 हमको ये भी चाहिए, ये भी चाहिए. So that means what we can say now here, अगर if this y1 से complement नहीं तो here, if you have taken this x1, if I have taken the x1 equal to b, अगर हमने ऑप्शन से चूज किया तो टेल मी ना हुई है ऑप्शन से x1 is equal to b, x2 equal to 0, x1 is equal to, अगर मैंने if I have verified this option now here, option A से x1 is equal to what they given you, tell me. x1 is equal to b and x2 equal to what, tell me now, 0, and x3 equal to what, to tell me now, a na. If I put this x1 is equal to b, so then what I will get, this y1 value, tell me now here, that is b bar into b plus x1 is what, tell me now, b into a. So ये a b आएगा ना इधर. Next this one. So what about this y3, y2, you tell me now from this, x3 is equal to a, x2 is equal to 0, and x3 is equal to what, tell me now, a into what, tell me now, ab. So that's why what will come here, y2 equal to what, ab आएगा. So then option A is correct. So here in this problem, verification से करना पड़ेगा. Verification से किया तो easy बनेगा. Next one. In the figure shown, ith full adder block of a binary adder circuit, C1 is the input carry, Ci plus 1 is the output carry of the circuit. Assume that each logic gate has a delay of 2 nanoseconds with no additional time delay due to the interconnecting wires if the input AI and BI are available and stable throughout the carry propagation. The maximum time taken for an input Ci to produce the steady state output of Ci plus 1 is. Okay, fine. And listen carefully now here this problem. Now this is the given this has assume that each gate will take a delay of how much? 2 nanoseconds. Now let us say t is equal to 0 if we have given the input. Now so this will take the 2 nanoseconds to produce output. So output हमको कब मिलेगा? So 2 nanoseconds के बाद मिलेगा. That means at 2 nanoseconds मिलेगा. And this input. So this is also 2 nanoseconds. ये भी हमको कब मिलेगा? 2 nanoseconds के बाद मिलेगा. Now this is also 2 nanoseconds. This also 2. This also 2. They are asking to find only carry only Ci plus 1. So let us see this part now here. Now this fellow which is available when you tell me now here at 2 nanoseconds available. Okay. Now this fellow 2 and this fellow is when is available, you tell me now here at 2 nanoseconds this fellow is available. And when this input is available now here at 0 this fellow is available. Now you tell me now here when this output will come, you tell me now here this is input will be available at 2, this will take another 2 nanoseconds. ये आउटपुट कब मिलेगा? 2 plus 2 4 nanoseconds के बाद मिलेगा. This output, when this output will be available, you tell me at 4 nanoseconds will come. And this input is available at 4 nanoseconds. This is available at 2 nanoseconds. Now you tell me now here when this output will come, you tell me here 4 plus 2, that is what I mean 6 nanoseconds के बाद मिलेगा. So that means कितना time लगेगा, you tell me? That is 6 nanoseconds लगेगा. Next. A multiplexer with a 4-bit data selector. 4-bit data selector is a. So how many data selector means selection lines are how many? 4 are there. Selection lines are 4 means what, tell me now here? So how many inputs are possible, you tell me? Selection lines are 4, that is S3, S2, S1, S0. The 4 selection lines are there, number of selection lines. We have the one output Y. Then how many inputs are possible? 0, 1, 2, up to 15 tak possible now, tell me? Up to 15 tak possible now here. How many inputs are possible, you tell me now here? So that is totally 16 inputs are possible. So this is called as what, tell me now? 16 cross 1 marks I can say. This is called as a 16 cross 1 marks. Next. The number of full adders. Okay, full and half adders required to add 16-bit numbers. Okay. Yes. How many required, you tell me now here? So for this, now you tell me now here, for the addition of 16-bit numbers, I can go all the 16 half adders I can use. Yes, so 16 full adders we have to use now here. What else we can do? 15 full adders will go plus 1 half adder. Why? Because for the LSB bit addition, only 2 bits are there. There is no 3 input. Carry bit is 0, na? There is no. That's why half adder chalega. So 1 half adder plus 15 full adders required. Next. Which are the following is the output of the Boolean functions? The output of a Boolean function they are asking. Now you can see now if I call this output is Y, this is Y. Now you tell me now F. F is equal to what? Tell me now here. Y plus B. This is B and here will come it as B bar. So this is Y plus B bar. And what is this Y, you tell me now here? You can see now here what are the min terms are there. So Y min terms are what you can see? 0, 2, 3, 4, 6. So 0, 2, 4, 6. Okay, so that means Y. 0 means what I can say now? A bar, B bar, C bar. 2 means A bar, B, C bar. Plus 4 means what? Tell me? A, B bar, C bar. And 6 means what? Tell me now? A, B, C bar. So from this F is equal to what I can say? Tell me now here. A bar, B bar, C bar plus A bar, B, C bar plus A, B bar, C bar plus A, B, C bar plus what? Tell me now here? B bar. Now you can see now in this, I'm taking the B common. So if I take the B bar common, so what I'll get now here? B bar into A bar, C bar plus A, C bar plus what will be 1 plus what tell me now here? A bar, B, C bar plus A, B, C bar. So then that is F is equal to what I can say? Tell me now here? B bar plus, yeah, by combining these two here, it will come to be a what? Tell me now? B, C bar we have taken common. then it is A bar plus A is 1. So that means finally this F will becomes as what element of B bar plus BC bar. So then mingle property if we apply, that is B bar plus C bar. Then is there. So R we can write this as simply BC whole bar I can say now. So option D. Next one. The output expression of the digital circuit shown in the figure is, so they given the bubbles given, so max terms will come. Okay, now you can see here carefully. Now here, so I can say this as min term 1 bar will come because of the bubble, and this is min term 2 bar, and next this is M4 bar, right, and this is M7 bar. Now from this F is equal to, what I will get to tell me, M1 bar, M2 bar, next M4 bar into what terminal here, M7 bar. Now De Morgan's laws, so it will be what terminal here, by taking this thing here, this is M1 bar whole bar plus M2 bar whole bar plus M4 bar whole bar plus M7 bar whole bar. So this is nothing but what, tell me, M1 plus M2 plus M4 plus M7. These are the minterms now. So minterms, how we can write sigma or pi? Sigma 1, 2, 4, 7. And what's the option you tell me? Option B. So there is a chance to go for option D also. Option D is wrong. Pi means what? Tell me, product max. Next one. Yes. Take this problem. Here a problem देखने के बहुत डर लगेगा, but easy है. Consider the digital circuit as shown in the figure. The binary input sequence is adjusted to turn off the LED. The turn on the LED, which are the following binary combinations will satisfy, and which input case the LED will turn on. They given this as given as LSB. This is the MSB given like this. Okay. Now look at now. So if you see carefully the functioning here, D naught. So what will come here is LSB. So that's why here what I can say now here, B bar, A bar will come. Here this is what element of B bar A, and this is what element of here B A bar 2 means this is what element of B A, right. Now you can see now if you want to verify this as a option C, we are verifying here. That is what tell me now here. So this is C value given like this now. So C verification, A value 0, B value 0, C value is 1. Yeah, tell me now here. If we have taken this is A value, how much is A value? Tell me. A value 0, B value 0, C value 1. Tell me. 0, 0. That means what now here? This is 1 now. This output is 1. This is what element of 0. This is what element of 0. This is what element of 0. Now this is 1 and this is 0. This is 0 means this is 1, this is 1. And C is 1. Okay. Now A value we have taken as 0 and this is taken as 0. If you have taken A value 0, what will be the output to tell me now here? 0 will come here. Here, what will be the output will come here? 1 will come. This is 1. So this is indicate 1, 1 means 1 only now. This is 1. This is 0. So this is what tell me OR gate. If one of the input is 1, so that means what happened to OR gate value? So this will directly 1 only now. Directly 1 only. So this means 1 and 1. This is which gate is XOR gate. XOR gate, if both inputs are 1, 1, output क्या बनेगा? You tell me now 0 बनेगा. Now you see this thing to turn on the LED, which are the following binary. Binary comment does not make the LED to turn on. That means we need turn off the LED. So then which combination will be turn off the LED? So option C will turn off the LED. Okay. Next. Right. And what is this one? This thing we have seen so many times. This is the binary to gray code now. Here BCD to gray code. Directly we can say na BCD to gray code converter. Next. A 4-bit parallel adder is built using 4 adders. If each full adder takes 44 nanoseconds to produce some bit. Sum के लिए कितना time लगेगा? Sum के लिए. So this is 44 nanoseconds. And then carry के लिए कितना here? So here and carry के लिए how much you tell me? 40 nanoseconds. Then the time required for the addition of 2 4-bit numbers. How much the time will required for the addition of 2 4-bit numbers? Tell me now here in case of parallel adder, ripple carry adder, delay remembered, ripple carry adder, delay which is given as n minus 1 into what we can say now here TPD of carry plus what I can say now here max of some delay comma carry delay, max of what tell me some delay comma carry delay. So this n minus 1. So how many bits? 4 bits. So that means 3 into TPD of carry is 14 plus max of what I can say tell me some delay 44 carry delay 14. So that means how much is value here? So here this is 52 plus what will be now 44. So this 42 now. So here this is what will be now 86 nanoseconds. Next, if a 2-bit binary multiplier is to be implemented using 2 input AND gates and OR adders, then the minimum number of AND gates and OR adders required is. We want to implement a 2-bit binary multiplier. So that means if you have taken A is equal to A1, A0 and B have taken as what tell me now here B1, B0. So multiply these two here, what will come here? This is A0, B0. This is A1, B0. So this is B1, A0, A1, B1. So here we'll get the sum S0. This is S1, this is S2. Now you tell me what they're asking here. How many AND gates required? Each product required 1 AND gate now here. So that means we can say here 1, 2, 3, 4. That means number of AND gates are how many we can say? Number of AND gates required. So how many required? 4 required. And the number of adders, Now tell me how many required now here. For the addition of this thing, we required 1 half adder. And by doing this thing here will come some carry will go now. So this also required 1 half adder. So that is totally 2 half adders required. 4, 2. Next, a gate has 2 inputs A and B. A and B and one output Y is implemented using 4x1 mux as shown in the figure. Now they ask it to find the function Y is. Now this is A, and this is A connected. Right, this is connected to B and B connected. Yes, tell me now Y expression here. So this is A bar B bar into A plus what, tell me now, A bar B into B plus what, tell me now here, A B bar into B plus what, tell me now, A B into A. Then this is 0 and so plus what, tell me now here, and this is 0 and this is what, tell me now here, AB. So you tell me now in this B common, so B into A bar plus A. So that is nothing but what, tell me now here, B is the answer. The option is C. Next, the number of select lines M required to select an output of 32 input line is, how many selection lines are required? So this mux must be 2 power 5 cross 1 mux hona padega. See is what we can say now. So the number of selection lines are how many? Number of select lines are how many? You tell me now. 5. Next one. If X number of 4 cross 1 mux, Y number of 2 cross 1 mux, Z number of 16 cross mux are needed to implement 128 cross 1 mux, then which of the following can be the value of X plus Y plus Z? Okay. Now you see this thing here. If you have taken this odd, so here X, Y, Z they given. So how many ways we can arrange them? So this is the given this as X, Y, Z. So how many ways we can arrange them? 3 factorial ways we can arrange. Means what, tell me now, 6 now? Many ways. Now let's see the different combinations. Which combination I can be suitable when you see here. So if you have taken this as combination X, Y, Z, this is one combination if you have taken. Now you tell me now here X. So 128 by 4. How much is value? 32. Now here 32 by 2. That means 16. 16 by 16, that is 1. So how much is value? 49. Option is there? No. Next, if you have taken it as X, Z, Y. Tell me now this combination X means 32. 32 by 16. Okay. So here this is what, tell me now, 32, 16, 2. 2 by 2, this is 1. How much is value? 35. Option is there now here. Yes, we have these so many combinations. If you want, we can try the other combinations also. Check whether satisfy or not. Y, X, Z, other combination. First, if you have taken a Y means 2. So here 128 by 2 means 64. and x means what? Tell me. 64 by 4 means 16 plus 1. How many? Tell me now. This is 81. No option. Next, what else combination? You tell me now here. Y, Z, X we have taken. Y we have taken means what? Tell me now. 64 and Z means what? Tell me. 16. 16 fours na 64 plus 4. This is 1. So how much is value? 69. Next, if you have taken the Z, X, Y we have taken. First to Z we have taken. So 128 by 16. How much is value? 8. Yes. Next one is X means 4. 8 by 4. 2. 2 by, yes, 1. So this is 11. That means X, Z, X, Z, Y, X. Z is what? Tell me. 128. So here 128 by 16 means 8. 8 means Y value, tell me 2. So 8 by 2. This is 4. 4 by 4 is 1. This is how much? You tell me now. 16. So you can see only this is the option. 35 is there. Agar if there is a more than one option is there, we need to choose those options also correct. So in this problem, they can set the MSQ also, isn't it? Right. Okay, that's for this today's sessions, and do follow this series regularly, and we'll continue the remaining problems. And so we have given us, so this is never before offer is waiting for you. That is for 2024 KDA, this Unacademy subscription, that is just 6,999 only. Use this opportunity before it going to expire. So here you have great learning experience. The top-notch content is at the most affordable price. Chalo, let's meet in our plus course. See you. Bye-bye. Take care. Let's crack it.